Yeah, excellent. So I just want to go over the basics of ANC, the measurement or the result that you get. So it would just explain what that actually means. So it's one of those things, a lot of people talk about this headphone is 20 dB ANC or another one's 30. What's your number?
Right.
And we like to see a number, but people use these numbers a little bit differently. So it's not always consistent. I'm going to just measure one. That's actually the measurement left over. I'm going to measure this unit. So I start with, how we do it is we start with the ANC switched off, and we just put the headphone on the tester, and of course there's measurement microphones and everything built into that. So the sound is going to come from the outside through the headphone and into those measurement microphones, and we'll get a reading essentially on that noise.
Okay. Whoa.
So I don't know if that bursts in too loud or not, but
No, it's fine. And we can at least hear what's going on as you're going through the demo here.
Yeah, exactly. So we just generated it's called a pink noise signal. Actually, just happens to be a pink noise, and so there's that noise coming from outside to inside with the ANC switched off. So now I'll switch it on. I'll repeat the same measurement, the same noise from the outside, and then we'll compare what did we get when it was switched off to what do we get when it's switched on.
Okay.
And this is the answer. So I'll just take a one step back, and we have something called the noise spectrums first.
Okay.
So
zoom in on this. So we got a wider shot of the ZUMI, the test fixture now.
You do bump that a little bit. Should be a bit pretty close, isn't it?
Yeah, no, that's good. We can see what's being measured in this view.
I don't want to scrutinize this too much, other than to say that what we're looking at is that noise split up into all the frequencies that were coming out. So it's enough to say that pink noise has low frequencies and high frequencies all mixed together and to a noise signal. And so if we were to look at any given frequency point, starting at 10, 100, 1K, 10K hertz, we can read off and see how much SPL we were getting at those different noise levels. Mm-hmm. And there's two curves that are when we had the thing switched off, and two curves when we had it switched on. And you can just see that there's a gap between the two. So those frequencies have been reduced.
Okay, so the top line is on or off, and
the top line is when it's switched off and there's nothing there. It's just the noise coming directly from that speaker into the measurement microphones. And then we switch it on. The level at those frequencies, sort of between 100 and 1K usually, reduce. And what we'll do is we'll actually take those two curves and we'll subtract them and look at exactly just the difference between them, rather than trying to pick through that and see what the difference is. And this is it here. So the maximum difference is at around almost 200 hertz. That's called the peak. And the peak point on this headphone is around, I'm getting 32 and 33. So we could call it 30, you know what I mean? So
no. Why would there be an unbalance between the two cups, the two headphones? Is that just
in this case, it's going to that'd be quite common because it'll come down to manufacturing tolerances, basically.
Okay.
For this particular unit, it's been knocked around a little bit. I've had to play with it, taken the earpads on and off 100 times. So one side's probably a little bit worn out compared to the other. You would like to see it probably more balanced than that, but that's not bad. You won't hear that. You won't be able to tell that difference.
Right.
So we had a peak point, and we just labeled as the peak values. And that's often what's used as the ANC value that people talk about. It's that absolute peak point. I don't really like that because it doesn't capture the full effect. That is to say, you could arrange things to have quite a big number for your peak point, but actually the ANC is very narrow. It's not doing a lot of work. So what we do is we actually calculate that total area under that curve. So you sum up all of that space.
Right.
And you calculate a number, and here it is here. So actually we have, it's 26.7 or 26.8 in fact, so call it, it's almost 27 and then 26, 27 and 26. So that's a better representation when you're comparing headphones of what the ANC level is. So just to be very clear, this is actually the sum of log of x multiplied by the magnitude. So you don't need to worry too much about that. Again, it's just if you were to see what's the total area if we would fill up that hole. I should point out that there's 0 here. So in fact, I'll just quickly do that. If I have nothing, and I still have nothing, I just end up with 0.
Right.
Nothing changed between those two measurements. So I just get a flat line at 0 dB.
So somebody using this test fixture to compare maybe some ODM headphones or even perhaps a factory claims that they have this peak ANC ability with their product, but
yes.
Just having the peak doesn't necessarily make it the best ANC product, because it's the sum of that ANC reduction that you want to target for, overall a better product in terms of its ANC performance.
Definitely. But in fairness, in most cases, the peak and that total area number actually scale together. So a higher peak means a larger area. So it's not a bad figure to quote, but I like to see directly what's the total area, what's the total amount of noise that's being cancelled essentially. And so those numbers, we just saw the other one was 26, 27, I think. Let's have a look at this one.
Yeah. Somebody
else's headset. We're not going to worry about whose exactly. This is just. So that previous one, I just stored the shadow line. You can still just see it there. Right. So if you can flip the switch. Now then, let's see should we just zoom in a bit closer? Yeah, okay. So this headset, I've got a peak at around 22 and the total area, I've got 17 and a half-ish, let's say. And you can kind of see, I'll just disable those annotations so we can see the shadow line. There's that whole bunch of area that the first headset filled in with noise, had noise reduction that this one doesn't. So it's a lot smaller area. And yeah, that figure is lower also, in fact, by almost 10 dB. So what that means to say is the previous one, we had a peak of minus 32, I think it was, and this one's at a peak of minus 22. Our total area is actually similarly down by 10 dB. So what I say, those two do have a relationship, but I'm going to just go and find a unit that is, let's say, not the highest quality, and we'll see how that affects it.
Okay. So yeah, just everybody, Simon jumped into this very quickly. We forgot to introduce ourselves here in what we're doing here. So yeah, this is something we're going to try to do every week. And so this week's topic, as you guys, if you're watching, already know, is we're kind of detailing when you're doing some measurements of ANC headphones. What does it actually mean when you see these charts on, in this instance, a ZUMI system tested measurement? So let's just continue with Simon's demonstration with another pair of headphones.
Right. So I've been looking at a couple of, let's say, fairly standard, good performance stuff. Here's one that is not too bad, but hopefully it will just demonstrate to us the difference between something that's very good and something that's not. That was ANC off. Now I'll just switch it on. Yep. Okay, so we've got a similar peak in this case, 20-ish, good to say 21, but our actual area under the curve is a lot less than that previous model.
Okay.
So if you were to compare those two, if you were to listen to those two, you'd say that that previous one had more noise reduction. But if you were to just look at the specs and say, well, this one's 20, 21, and this one's 22, there's much more than 1 dB difference. And so that's why it's good to look at that area under the curve. This is quite a small area under the curve while hitting a peak value. Okay, good. So I'll just remove those annotations again so we can see there's an ANC curve. It sort of starts at about 0. Usually you can't cancel down to 0 hertz. So right at the bottom frequency, it will be about 0. And in the high frequency range, it will also generally be about 0. There's two certain reasons why you can't really do active noise reduction at the very high frequencies, to do with wavelength and resonances and so on. So it's all concentrated in this range, sort of in the tens of hertz up to say 1 kilohertz. Some will do a bit higher than that, depends. In-ear earphones maybe can go a bit better than large headphones in terms of the range. And then we're generally going to see some area scooped out of there. And the goal is to try and get as much area scooped out as possible. Mm-hmm. And that was this number, the area under the curve.
And just a lot of what people do with the active noise canceling headphones, the digital removal of the noise in the lower frequencies, but then is it not correct that a lot of the noise reduction in the higher frequencies is done with mechanical, both like the seal and the cup and these kind of issues?
Okay.
Approaches?
Yep, exactly. So let's just demonstrate that. So that would be what happens. Would be comparing what happens when there's no headset on your head, compared to when you do just put a headphones on or an earphone without worrying too much about the active part of it, just the passive. So I start off just with nothing. And that gives me a baseline. That's the noise from the outside world. Then I'll put this headset on with no ANC switched on. And that's what you're talking about there. I'll just remove that curve. In the low frequency, it's more or less at 0. There's almost no effect from the headphone. And then it starts to drop down in the high frequencies. So that's just the effect of the headphone blocking the sound from the outside world. Let's take something like this. That one's a bit obvious. Let's go back to that first one. This is probably not that spectacular in terms of its passive noise blocking. Try this. I think this one's quite good. It's got juicy air pads and it's quite well sealed in the rear chamber and everything. So it's a lot of work for the sound to get to the inside. Mm-hmm. Okay, so actually that's interesting. I have ANC switched on this one. So you can still see, if you remember, that ANC kind of V-shape effect in the picture here. Mm-hmm. Yeah. I'll switch the ANC off and repeat it, so we'll remove that part of it. Then we'll just see just the passive. There we go. So this the top part, the high frequency part of the curve stayed the same. We just, by not using the ANC, we don't have that reduction in the low frequency anymore. But that's very typical. It would just basically reduce more and more sound as the frequency gets higher and higher. So high frequencies don't pass through solid materials as well as low frequencies do. It's a bit like if you imagine if you're in two adjacent rooms and someone's talking in the next room, you can sort of hear the murmur part of the voice, but you can't hear the high frequency part that gets blocked out really well by walls or solid materials. But the low frequency can get through fairly well. So you end up just with that murmuring thing. And that leads back to what's the benefit of active noise reduction is that you can remove that low frequency stuff that you can't get rid of just by putting, like a mechanical barrier in the way. Like good old-fashioned, workers' ear muffs that just block the sound. They do a fantastic job at high frequency, but they're not that effective at low frequency. Whereas noise cancelling will complement that low frequency part very well, but it can't really do high frequency.
Right. So it obviously would be more challenging to do ANC in earbud style products where you have a barrier or...
Not necessarily the case. The earbuds would be more difficult just because the space is very limited, but there are certain benefits as well. So for example, one of the things is with an ANC system, you have a microphone located somewhere for feed forward. Okay, don't worry about the detail, but somewhere on the outside of the air cup, you have a microphone that's picking up that noise signal and then passing it through a filter and out through the speaker. And when it comes out of the speaker, it should be the opposite of the noise that's been making its way through. In a big headphone, the distance between the microphone, sensor microphone, and where you're going to pump out that sound is quite large. And so that has effects in terms of the wavelength, how far into the future you can predict, or something. We could say something like that, essentially.
Okay.
When you have a small earphone, your sensor microphone is very close to, or a lot closer to, the eardrum, essentially. So you can do a higher frequency, a wider bandwidth of noise reduction.
Okay.
So earbuds actually can do very, very well for feed forward. Feedback, again, it's as much a problem of space as it is anything. In a big headset, feedback microphone is you put the microphone inside the ear cup next to your ear. Whereas feed forward is the microphone on the outside.
Right.
Okay, so I didn't want to dive off into the technical stuff too much. It's just these headphones so far actually have been a combination of feedback and feed forward. It happens. You don't see any difference from the outside when you're measuring it. You don't see exactly that difference.
So these have all been hybrid ANC design?
Not all. There's been some feedback only. This one is actually a hybrid.
Okay.
The one that gets 30 dB. So generally, just with feedback only, you wouldn't be able to do much better than 20 and a few dB.
Okay.
There isn't like a basic physics reason. It's just that acoustic system really limits you to around the 20 dB. You can go a bit higher. So if you want to reach the 30s or more, you need to have hybrid feed forward and feedback.
Okay, that's good.
And then feed forward, you're limited. You're not limited, but it's hard to do a lot better than a sort of a 20 as well.
Okay. So those are good things for people to know when they're looking at a product spec. Is it feed forward, feedback, or hybrid? And what can you expect from it? So knowing those expectations, and then when you measure them, you should see if it's up to par based on the approach to ANC.
Yeah. So that's one of the things. When somebody advertises my feedback, I have a feedback 30 dB. It's probably not. It may be hybrid or some other, because it's not really possible to do that in a headphone structure. I mean, if you went to some real extremes, it's possible, but anything practical, it's not really going to be much over 20.
Right.
Just with feedback, I should say. Feed forward is not really limited in the same way. But for different reasons, you'd end up struggling to do much better than, say, 20.
Okay. All right. So what else would the people, besides benchmarking and seeing what the area under the curve, what other kind of information should people be taking off when they are measuring or benchmarking a product?
Yep. So let's cover one other point. As we've talked about the taking that scoop out of the curve and reducing the noise. There's one other part to look out for, and that is adding noise. So I'll use this set again because it has a bit of noise addition. The others don't really have it so much. So I'll just repeat that measurement. Let's repeat that measurement. We'll get the curve for this one. Okay, so I'll remove that one and let's show some details. Now, we also look out for what is the maximum point that goes past 0, so it actually adds some noise. So one of these, it's one of the elements of the system is that it's unavoidable. At some point you have to get back to 0, and you can have a little bit of overshoot. So in this case, we've got like plus 3.5 dB, which is a little bit high. So you're actually adding some noise at this frequency, and that can give you quite a seashell effect if you're wearing it. Let's say you're in an aircraft or something. If you put on something that doesn't really have any overshoot or very low overshoot, you just reduce the noise. When you put on something that does have this noise addition, you get that seashell effect where frequencies are boosted up, and it can be a little bit unpleasant. You want to watch out for that.
Okay.
So interesting, just and this measurement also to mention, So I just dumped the headphone on, and I can see that that's blue. The right-hand side is quite a bit different to the first time I measured it. They were both around 20-something, 21-ish the first time, right? So I probably just didn't seat that very well. So I'll give it a little wriggle, and we'll run it. Yeah, that's seated it a bit better. So I guess that also, and in fact, when we got it better seated, that overshoot moved down in frequency and increased a little bit. So it's quite sensitive to the acoustic setup as well. So I think maybe that covers it just for this first round.
Sure.
At that level, yeah.
So yeah, let's. How do I cancel spotlight? Let's try to.
Your background's nice.
Thank you.
Yep. I've just got a black piece.
There we go. Okay, so yeah, just so everybody who's watching wants to know what's going on here. So Simon is with ZUMI Systems. He's based in Japan. And my name's Dave Lindberg, and we run the sales and marketing for ZUMI Systems. And so today we were just going through a quick demonstration on with a ZUMI HPA 85. This is what you can do in terms of taking products, measuring them. This is probably for a benchmarking application, I would guess, unless you think of other applications where you'd want to be able to know what the ANC means, Simon. What besides benchmarking?
Yeah, you'd be doing it for benchmarking, just to debug, to find out about if there's any problems, and etc. So I guess you could bundle that all in as benchmarking, but there is always a need for that just bench top quick ANC measurement, so you can understand what's going on with any headphones. It's sometimes hard to determine just by listening to it, especially if you don't have a lot of background noise and you pick up a sample. You can't really tell too much difference because it's already too quiet. So you want to be able to put it on the tester and get a number off it.
Right.
What's the real number?
Okay. So yeah, so anybody wants to know more about the ZUMI system and how they can perhaps use it with their company, please reach out to us. Put the contact information here. And we're going to start a channel where we talk about different features of the ZUMI Systems products and go over this maybe once a week or bi-weekly, something like that going forward. So thanks.
I think we'll just cover a range of acoustic topics because there's a lot of, let's say, a lack of understanding in certain areas. So we can kind of expose a little bit of what's going on.
Sure. All right. So yeah, thanks everybody for watching, and click subscribe, and you can keep updated with our progress here. So have a great day, and thanks, Simon, for taking the time.
Thanks, Dave.
Okay, bye-bye.